A balanced diet is about taking in the recommended portions of protein, carbohydrate, and fats. The American Heart Association recommends that the fats should make up 30% or less of our daily diet. The right combination of fats is critical to life. Fats are an important source of energy. They're essential for growth and development, and they help regulate blood pressure, heart rate, blood clotting, nerve transmission, and temperature control. So why have fats, or more accurately, some fats, gotten such a bad rap? Well, the answer involves cholesterol, that waxy substance that's critical to the production of some hormones and vitamin D. It's important to limit the amount of cholesterol we eat, but cholesterol in the bloodstream is what's really important. High blood cholesterol levels increase the risk for heart disease. The biggest influence on blood cholesterol? The mixture of fats in your diet. Now, it's the liver that actually makes the cholesterol, but once it's made, in order for it to be transported in the bloodstream, cholesterol has to hook up to another molecule. And the molecule it hooks up to is part fat and part protein. And it's called low-density lipoprotein, LDL, a small molecule. When there is too much LDL cholesterol in the blood, it can be deposited in the walls of the heart's coronary arteries and cause a blockage. This is why LDL cholesterol is often referred to as bad cholesterol. On its way back from the blood vessels, however, it's transported by a larger molecule, high-density lipoprotein, the sibling of low-density lipoprotein. High-density lipoprotein cholesterol makes it less likely that excess cholesterol will get stuck in the heart's coronary arteries on the way back to the liver. Therefore, it's often referred to as good cholesterol. And this brings us back to fats. As I mentioned, the types of fats you eat determine your blood cholesterol level. So what is a fat? Well, that requires a little bit of a chemistry lesson. A fat is basically a chain of carbon atoms with hydrogen atoms thrown in, and at the very tail end, a few oxygen atoms for good measure. Carbon's the main player here. It creates the chain, and carbon's atomic structure allows it to hook to 4 other atoms at one time. If you have a chain of carbons, then 2 of those atoms' places are occupied by carbon at all time, but there are 2 other spots, one above and one below, that can take other atoms. And these are usually filled with hydrogen atoms. If you were to fill all those spots with hydrogen atoms, we call that a saturated structure, and we call the structure overall a saturated fat. A carbon chain filled with hydrogen atoms with some oxygens at the tail end. Now, if we were to remove a couple of hydrogen atoms at one spot between 2 carbons, and instead of having those hydrogen atoms there were to doubly bond the carbons together, we call that a double bond. And because several of the hydrogen spaces have been evacuated, we call that an unsaturated fat. If the chain has only one double bond, it's a monounsaturated fat. If the chain has 2 or more double bonds, it's a polyunsaturated fat. Now, if you take an unsaturated fat with one of those double bonds and you heat it up and you add hydrogen, you can actually change the way the hydrogen would normally attach to that carbon chain. Usually, hydrogens will go on one side of the chain. But the chemical reaction causes one hydrogen to cross over to the other side of the chain, so that the hydrogen atoms now sit across from each other. I think you know where I'm going here. When those hydrogen atoms, through heating, go across from each other, we call that a trans fat, because trans means across. We first started making trans fats when concern surfaced about the health effects of butter, which is made of saturated fats. By hydrogenating vegetable oil, that is, adding hydrogen atoms to create trans fats, we discovered that liquid vegetable oil turned solid. And we began immediately to make sticks of margarine. Between 1950 and 1980, we thought what we were doing was actually healthy. Tufts University nutrition professor Alice Lichtenstein says that back then anything was good if it decreased saturated fat consumption. But then the studies began to question trans fats also. Unsaturated fats, those with one or more double bonds, they're good. They lower bad LDL cholesterol and they raise up good HDL cholesterol. Trans fats, those liquid to solid hydrogen creations, are the evil twin. They raise LDL cholesterol and lower HDL cholesterol. Unsaturated fats lower rates of heart attack and stroke. Trans fats raise those rates. And finally, what about those saturated fats? Well, they're still bad, but they're not as bad as trans fats. Saturated fats actually raise both LDL and HDL cholesterol, but the net effect overall is more harmful than it is good. Little chemistry lesson to help you choose the fats for yourself and for your family's health. For Health Commentary, I'm Mike McGee.